Good day. My name is Sir Kev, and welcome to Science Grade 10, Quarter 1, Module 5, Evidence of Plate Movements. Today's lesson is MELP number 5, Evidence of Plate Movements, and you are expected to enumerate the lines of evidence that support plate movement. You have learned from your previous lessons that lithospheric plates, or the solid part of the Earth, are gradually moving to form different geological events such as earthquakes, mountain buildings, and volcanoes. But what causes these plates to move? What is the evidence that the Earth's plates are moving? These questions ignited our scientists' curiosity to look for answers and lead to the development of the following ideas: continental drift theory, seafloor spreading, and Earth's magnetic reversal. Today, we will be learning that the Earth's plates are moving through the following evidences. The first evidence of plate movement is the continental drift theory. Well, have you seen a world map before? Definitely yes. You have seen one. So did you notice that the eastern border of South America and the western part of Africa seem to fit together like a big jigsaw puzzle? Well, if you said yes, then you're thinking like Alfred Lothar Wegener. He was a German polar researcher, geophysicist, and a meteorologist. He is remembered as the originator of the continental drift theory by hypothesizing in 1912 that the continents are slowly drifting from the Earth and is once a large landmass called the Pangaea. This is a Greek word which means all Earth. Wegener's curiosity about the idea of drifting continents started when he noticed that the edges of South America and Africa in a world map could be fitted like a jigsaw puzzle. So, would fitting edges of continents be enough proof that the continents are drifting? What are the other pieces of evidence gathered by Wegener to support his continental drift theory? Alfred Wegener collected diverse pieces of evidence to support this theory, including geological fit and fossil evidence. Geological fit evidence is the matching of large-scale geological features on different continents. It has been noted that the coastlines of South America and West Africa seem to match up. However, more particularly, the rock terrains of separate continents confirm as well. In addition, the existence of coal deposits in Antarctica suggested that it was once located near the region of the Earth where the climate is enough to support complex life forms such as plants and tall trees. Well, fossil evidence can be attributed to Alfred Wegener mapping out the distributions of the four Permian and Triassic fossil groups and used it as a biogeographic evidence for continental drift and land bridging. So these fossils are the Mesosaurus, we also have the Cygnognathus, the Lystrosaurus, and the Glossopteris. They were found to be present in previously adjacent continents that drifted away from each other, like for example, the Cygnognathus can be found both in South America and Africa. Currently, both continents are very far away from each other. Now, what are the other evidences? Climate change evidences such as glacial deposits at current equator and fossilized palm trees in Greenland also strengthens the theory. The map shows why according to the placements of current continents within the Pangaea. Now, the second evidence of plate movement is the seafloor spreading theory. The idea of continental drift circulated in scientific circles until World War II, when sounding gear called sonar produced new evidence of what the seafloor looked like. The gear, developed in the 1930s, bounced sound waves off the seafloor to determine its depth and features. It happened that the command of one attack transport ship, the USS Cape Johnson, was given to Harry Hammond Hess, a geologist from Princeton University. Hess, in his late 30s, wanted to continue his scientific investigations even while at war, so he left his ship's sounding gear all of the time, not just when approaching port or navigating a difficult landing. What Hess discovered was a big surprise. So what did Harry Hess and his men accidentally discover when they explored the oceanic floor? Were they able to locate the start of all the movements on the Earth's surface? Moreover, did the Harry Hess team gather much strong evidence to support the claim that continents are drifting? Now, the ocean floor exploration continued, and by the 1950s, other researchers had found that the huge rift ran along the top of the mid-Atlantic ridge. This enabled Hess to understand his ocean floor profiles in the Pacific. He discovered that the bottom of the sea was not as smooth as expected, but full of canyons, trenches, and other volcanic sea mountains. He realized that the Earth's crust had been moving away on each side of oceanic ridges down the Atlantic and Pacific Oceans, long and volcanically active. He published his theory in History of Ocean Basins, and it became to be called the seafloor spreading. In the early 1960s, dating of ocean core samples showed that the ocean floor was younger at the mid-Atlantic ridge, but progressively older in either direction, confirming the reality of seafloor spreading. The last evidence of plate movements is called magnetic reversal. Well, further evidence came along by 1963 as geophysicists realized that Earth's magnetic field had reversed polarity many times, with each reversal lasting less than 200,000 years. Rocks of the same age in the seafloor crust would have taken on the magnetic polarity at the time that part of crust formed. Sure enough, surveys of either side of the mid-Atlantic ridge showed a symmetrical pattern of alternating polarity stripes. A magnetic compass can tell direction. The needle of a magnetic compass usually points to the North Pole of the Earth, which is actually the South Magnetic Pole at present. The crystallized irons in rocks found in the ocean floor act as a magnetic compass that can tell the Earth's magnetic field direction. So, what is magnetic reversal? How can magnetic reversal be used as evidence of the seafloor spreading theory? Now, the seafloor spreading was strengthened with the discovery of the magnetic rocks near the ridge, following a pattern aside from the fact that the rocks near the ridge are younger than those farther from the ridge. Magnetic reversal happened many times in the past. The occurrence of the magnetic reversal can be explained through the magnetic patterns in the magnetic rocks. These magnetic patterns allow our scientists to understand the ages and rate of movement of the materials from the mid-oceanic ridge. The magnetic reversal, also known as the magnetic flip of the Earth, happens when the North Pole is transformed into the South Pole, and the South Pole becomes the North Pole. This event happens because of the changing direction of the flow of materials in the Earth's liquid outer core. Over the last 10 million years, there had been an average of 4 to 5 reversals per million years. New rocks are added to the ocean floor at the ridge with approximately equal amounts on both sides of the oceanic ridge. And there we go. These are the 3 evidences of plate movements. Now let's go to the activity proper. Here's what you're gonna do. First, get the world map. Then, predict and construct the future world map in 1,000 years, 1,000,000 years, and 1,000,000,000 years from now. Finally, label or provide illustrations of evidences as to the movements of the continents in your new map. Example, fossil evidences, climate changes, and a lot more. Here's your guide question. Where will the Philippines be in 1,000 years, 1,000,000 years, and 1,000,000,000 years? Alright, now let's go to your assessment. Choose the best letter of the answer in each item. Write your answer in a separate paper. Number 1. The idea proposed by Alfred Wegener to explain the continental shapes and positions is also known as A. The Pangaea, B. Plate tectonics, C. Continental drift, or D. Seafloor spreading. Number 2. In the mid-1900s, scientists mapped mid-ocean ridges using what? A. Satellites, B. Moons, C. Stars, or D. Sonars. Number 3. Wegener suggested that coal beds discovered in Antarctica indicated that this continent was A. Once underwater, B. Always frozen, C. Once near the equator, or D. Part of Africa. Number 4. The seafloor spreading theory states that A. All continents are drifting, B. Ages of rocks near a ridge are older than the ones far from it, C. Fossils of plants and animals are found in almost all continents, or D. Hot and less dense material from below the Earth's crust rises towards the surface at the mid-oceanic ridge. Number 5. What strong evidence discovered by our scientists that Earth's magnetic reversal had been happening in the past? A. The magnetic reversal occurrences supported by magnetic patterns in magnetic rocks found on the ocean floor. B. The ages of the rocks on the ocean floor are constantly changing. C. The magnetic field of the Earth becomes weaker. And D. The Earth's magnetic field is fluctuating. Alright, congratulations for finishing today's lesson. Here are the references that you can use. When the darkness envelops the night sky and the battle has begun, the wolf shall scream our perish, but we shall taste triumph at the dawn of the rising sun. Hiraya Manawari from Rafael Kevin Ainagal, a lifelong learner.